So the next problem we're going to talk about something that is absolutely impossible. Okay? We have two walls. And I'm going to have a rope that's perfectly horizontal extended between those two walls. Okay? And from that rope, I'm going to hang a mass. Now, we see this all the time, and that's not the impossible part about it. The impossible part about it is that the rope remains perpendicular to the wall. That this rope always remains horizontal. Okay? Now, why is that impossible? Well, it is impossible because of Newton's second law. The sum of the forces is equal to mass times acceleration. Now, there are three forces acting on this block. Now, I'm going to shorten this rope and just pretend that the block is hanging directly from that piece. The rope there just adds another component of tension. It's not all that important. Okay? So I'm going to have a tension in this direction and a tension in this direction and the weight of the block. Okay? So now I have the sum of the forces is equal to mass times acceleration. And when dealing with forces that are in more than one direction, which I do here, I have forces that are in the x-axis and forces that are in the y-axis, I like to say this instead. The sum of the forces in the x produces accelerations in the x, and the sum of the forces in the y produces accelerations in the y. Now, hopefully, just by putting that, you can see why this is impossible. But let's go through it. Forces in the x we're talking about in this direction. Well, I have a tension in this direction, and tension is the direction of the wire, pulling this way. And I have a tension pulling this way. So T1 minus T2 is equal to mass times acceleration in the x. Now, the block is being perfectly suspended. It's not accelerating, so that's equal to 2. I don't really have a problem here. I have T1 is equal to T2. There doesn't seem to be a problem here. This seems to be absolutely possible. Until I look at the y-axis. The only force that's happening in the y-axis is mg. The weight of the block, okay, is equal to may. Now, the only way that this can work is that this is somehow a magic box and there is no mass. Okay? But that's not the case. If I say that it's perfectly suspended and it's not moving or accelerating, is what I should say, this is 0. Okay? So I have a force of gravity pulling down, nothing pulling it up, and yet I have a situation where the acceleration is equal to 0. It can't be done. As a matter of fact, stringing a piece of rope from here to here and having it perfectly horizontal is also physically impossible. The less tension in the wire, or the less sag in the wire, I should say, the more tension it has, to the point where if you have no sag in the wire, your tension is infinite, because the wire itself has weight and it's pulling itself down. Okay? So not possible. You have to have at least a little bit of sag in order for this to happen. But that's why this is an impossible problem. You can't solve this. It's the only way, like I said, you can solve it is if the box weighed nothing, and then it's not a box.